Thank you for kind introduction. My name is Masahiko Yamazaki. Today I will talk about the CubeSat Systems Engineering education through short-term hands-on activities. So move on to the next slides. Okay, there is the challenges of CubeSat program knowledge transfer. The space industry needs radical cooperation among more diverse sectors, for example, other fields such as software, disaster management. However, sometimes it is difficult for engineers and non-engineers outside the space field to understand space systems engineering itself without practical experience and common languages, common models. So it is difficult to consider why and how to integrate new elements with space systems. And the university aspect, most university programs cannot sustain permanent professionals, and the documentation and its handling is also not sufficient. It is difficult to pass on the concept and management methods of design and development. In such situation, we started the CubeSat kit-based space systems engineering education since 2012 for CubeSat knowledge and technology transfer. In the 2012, we developed the HEPTA-Sat 1. There are just only the 3-layer electrical borders. In the 2016, we added the structure elements into it. And 2019, HEPTA-Sat 3 with model-based systems engineering parts. In the 2021, HEPTA-Sat Lite, we developed a more deep and more easy one. And we also developed the online courses to share this kind of training to all over the world. So this slide shows the annual training program movies of the HEPTA-Sat training program. The part 1 lecture about CubeSat. The part 2 is a self-learning part, CubeSat System Assembly, integration, and the test with textbooks. The students do the field test. After that, and part 3, they try to do the problem and the project-based learning with HEPTA-Sat Bus, and to understand the relationship between the operational and functional and the physical point of view and their relationship with design and development. This is the education to gain the knowledge necessary to think about satellite-based service with people from various backgrounds through hands-on experience for new entrants with limited prerequisite knowledge of space systems. We have conducted hands-on education in many places around the world. More than 600 people from over the 50 countries participate in the educational programs. There are annual training program for instructors. We call the CLTP, and the university educational program, for example, international space universities and the other area of the university. We also start the online workshops like that. Based on this experience, we thought it was important to provide these 3 steps. Step 1 is a CubeSat system assembly, integration, and tests with textbook to understand the functional and the physical elements and their relationships. It consists of the operational context and the choice of the elements, physical element and functional elements, and the assembly, integration, and tests it to the HEPTA-Sat Bus. In the second step, problem and the project-based learning with HEPTA-Satellite Bus to understand the relationship between operational and functional and physical point of view and their relation with design and development. There are user boards and new elements, and user add the new element to the user board, and the user add the user board to the HEPTA-Satellite Bus. And step three is a visualization of system design development, kind of the model-based systems engineering. So let's move on to the second part of my presentation about HEPTA Satellite Training Kit itself. We call it HEPTA Satellite Bus. The HEPTA satellite to simulate the actual satellite to ground station communication experience and system point of view. There are operators and satellite. There is a communication between the operator and ground station and the satellites, command and the data. And the composed of six functions and six primary subsystems, structure subsystem for supporting, electrical power supply subsystem for producing, storing, checking, and controlling powers, command and data handling subsystem for data handling, commanding, communication subsystem for, and ground station subsystem for communicating, and the sensor subsystem for sensing. And there are operational point of views, and functional point of views, and subsystem point of views, and physical element point of views. And there are decomposition flows and integration flows. So there is an experience how a system is composed of elements and subsystems to understand the relationship between the whole system and the elements. So this is the HEPTA Satellite Training Kit. It consists of 3D printed structures, and the solar cells, and the release detection switches, and the flight switches, and GPS, cameras, access ports, antennas. It's like a real CubeSat. And this is inside of the structure. There are 3-layer boards. The first layer board is the electrical power supply and the command and data handling boards. The second layer board is communication and sensor boards. The third layer board is the user boards. User can easily add the new elements. And there's a microcomputers, memories, and batteries, and thermal sensors, and 9-axis sensor. It means the angular velocity, accelerations, and the magnetometers. And there's a transceivers. Each layer borders connected, physically connected spacers and electrically connected pin sockets. So this training kit has a self-learning environment. The one is a textbook. The one is an open source library and forums. The inside of the textbook, there are overview of CubeSat and CubeSat system architectures, circuit level, and block diagram levels. And there is a programming, and there is a computer aided engineering point of view, and communication protocols like that. And the open source library and forum, there are all of the program for the HEPTA-Sat training. And the user can easily download and import into your environment. And also they can upload their software into it. So these textbooks and open source library and forum and the training kit is all inclusive. So easy access to space for newcomers, requiring only an internet environment and the laptop computers. So I will move on to the third part of my presentations about the training program. As I mentioned previous slides, there are 3 steps. One is the self-learning parts with textbook. One is the problem and the project-based learning steps with HEPTA-Sat Bus. The one is the model-based engineering parts. So move on to the step 1, step 2, step 3. In the step 1, step 1 is the CubeSat System Assembly integration and test with textbook to understand the functional and the physical elements and their relationships. And the focus is on mainly on the understanding, assembling, integrating, and testing the function of the CubeSat kit and carrying out it in a hands-on manner, step by step, from component level to the system level. There is a component A, B, C, D. They need to do the assembly and integration and tests to make a subsystem A. And there is a subsystem A and a subsystem B. Need assembly and integration and test it to make a satellite system. There are elements outside of the satellite and also need to assembling and integration and test. And participants focus these requirements, element requirements. Participants focus these interface requirements during the hands-on process. Step 2. Step 2 is the problem and the project-based learning with HEPTA-Sat Bus to understand the relationship between operational, functional, physical elements and the design and development process using new functional and physical elements. They try to do the mission design and implement it and test it, and finally conduct a presentation and then do that again and again to make accomplish the missions. This is the second step. The third step is a visualize of system design and development process. It started from the user needs and the mission requirement to the component manufacturer. And from the component manufacturer, they do the system assembly test and the system validations. The first step is a mission definition and clarification of requirement specification. Draw the use case scenarios. And the second part, they draw the state machine diagram or functional flow diagrams. And the third part, clarification of verification plan and verification items to make, and then they make a verification matrix like that. After reflecting on the first project-based learning, visualize it and apply the next project-based learning. Finally, conclude my presentation and future work. The HEPTA-Sat training program provide a practical space engineering education platform for engineers and non-engineers that can be learned in a short period of time to support radical collaboration among more diverse sectors. I think the hands-on experience with some level of complexity and expansibility like CubeSat is a good hub, good interface for connecting students with current and future disciplines like mathematics and space laws, computer language, and model-based engineering. We would like to conduct earthquake prediction and tsunami early warning missions in the near future by using open design CubeSat like HEPTA-Sat, which enables the transfer of knowledge and technology and university-originated satellite swarm observations. Finally, I will conclude my presentation and I will call for new training. Council Leader Training Program 11. CLTP is a training program for professors and instructors to learn how to conduct CubeSat or HEPTA-Sat training by experience. Participants are expected to teach their students after training. So just search the CLTP and please take this course, and together with us, let's create a sustainable development educational platform. Thank you for kind attention.